Welcome, I'm going to go through this piece of code I have made. The first line up here is include iOS stream, which basically loads the library iOS stream. The next thing is using std namespace, which prevents me from having to write it in front of every one of these. Then we reach the int main, which has the 10 variables right here. The first one is a string, second one is a char, third one is a boolean, the fourth one is a long double, fifth one is a float, sixth one is a long, seventh one is a long, and then we go to a signed short, an unsigned int, and a long, and an unsigned long. There are in the first one there is a small text piece called boo, and the second one there is the letter big B, capital B. In the boolean we put in false. In the long double we put in this huge decimal number. In the float we put in this. In the long I put in minus this huge number, and in the long I put in an even bigger number because it can hold more. In the short, so in the signed short, I put in minus 9,000 ish. In the unsigned int I put in a larger number because it's bigger than the short, and in the unsigned long I put in another number which is even bigger because it's bigger than this one. Now we reach this piece, which is it tells the PC that when you run this, whenever a cout goes, add the function precision and set it to 15. It basically means that if I didn't have this, the computer would not be able to print out all the decimals after the comma on the example the long double. But this allows it to. And putting it in front of all the couts, it basically counts for each one of them, so I don't have to write it just before each. When I type out one of the things, I basically say cout, which means that you stuff something out to the console. Then I've created a small thing to make it easier to understand when we point it out. So string boo, which is the first one, and then the actual thing that is inside it, then its size by using the size of boo, which gives us the size in bytes, and then also which, if you use size of times 8, it gives you the bits, and that's basically what each of these lines does for each of these. So let me just show you. So here you can see that it's gonna type out. Oh, let me just sneaky fix this. So here you can see if we follow this particular piece of code here. That's one. That string boo, inside it is boo, and its size is size of boo, which is 4 bytes, which is the size of boo times 8, which is 32. As per char b, it's a capital B that is inside it, and its size is 1 byte, which is 8 bits, and so on and so forth. Now, moving on, we also have this thing called typecasting, which is a part of the assignment. So I just made a small viewpoint of it here. So implicit typecasting is simply it's the basics. You give one variable the value of another, and in this sense we have this short x, which is 5,000, and we have this y, and I simply just say, well, y equals x. This means that y's value will now be 5,000. There's also the explicit version, where you add a little, which is basically that you take the short c, which is 9001, and you take your int l, and you stuff integer c into l. Now what this does is that before stuffing it in here, it basically says, okay, so you're no longer a short, now you're also an int. And then L will still have the same value, but it gives it more space in a sense. Another way to typecast is by using numbers in a char example instead of actual characters. The way to do this is to, you don't necessarily have to create this int, but if you use this int beef, which has the number 200, and then stuff it into char by using char as a function, you will end up getting the output of that particular character which has the number 200. Let me just show you. So we can see that in the bottom line right here, it is this weird ass looking L character with a small L. I don't know what it's called, but that is what is number 200 in the character library. And yeah, that was about it. Thank you for watching.